let's take a look at how to figure out the atom placement on a specific plane. So we're going to go ahead in this case and look at the atom placement for the face-centered cubic structure on the 1, 0, 0 plane. That's a face plane. And so the first thing to do is to figure out where the plane is. So a 1, 0, 0 plane, we kind of work in reverse and take the reciprocals. This will tell us the intercepts, right? So if I take the reciprocal of 1, it's 1. And then remember, these zeros then correspond to infinity. So this means that it's parallel to the y direction, parallel to the z direction, and it intersects the x-axis at 1. Right? So that's this plane here across the face. Okay, so that's the YZ plane. All right, so that's our 1, 0, 0 plane. And we like to use this sort of exploded view model because it's easier to see the structure and where the planes are. But we have to keep in mind when we go ahead and draw the atom placement that we need to be looking at the actual space filling model, right, where the atoms are enlarged and we see that the atoms, for example, are touching along the face diagonals, and that's very important. So I want to sketch that sort of view. Okay, so again, if I go ahead and look at the 1, 0, 0 plane, or in this particular case, let me go ahead and keep the labeling that they've actually done here. This would be a 0, 0, 1 plane. So let's talk about that a little bit, because that looks a little confusing too, because it looks like this plane is intercepting here at the origin. So whenever we do have a plane that goes through the origin, we always have to shift it by 1 unit cell direction. We can shift it in any direction that we want as long as it's by a unit cell vector. So in this particular case, what I will do is we'll take this plane and we'll go ahead and shift it up so that it's now located up here at the top. Okay. Now located up there at the top, you can see that the intercept along the z-axis is 1, and you can see that it's parallel now to the x and y axes. And that's exactly what we have here as the 0, 0, 1 plane. Okay. So this applies anytime it goes through the origin. We're just going to need to shift our plane. Okay, so we're taking a look though at this bottom plane in terms of the labeling. And you can see now again, since we know they're touching along the face diagonals, that when we sketch that, we're going to get this sketch here. And many times if you're sketching it yourselves, you know, and you can't draw a perfect square, that's certainly understandable. What you want to do is just go ahead and mark up your sketch to let me know, for example, that you drew a square. So if I go ahead and label these two edges as A, then I know that the intent there is to make a square, not a rectangle. I also could draw in the directions that the atoms are touching, and maybe just label touching, say, along face diagonals. Now everything's clear, and I know that that was your intent. Okay, so that would be our 0, 0, 1 plane for the face-centered cubic. One other point, we started this off by saying we were going to sketch the 1, 0, 0. All of the face planes in the cubic system are identical. So it actually doesn't matter whether we're sketching the 1, 0, 0, which is here, the 0, 0, 1, which is the top, or the 0, 1, 0, which would be this face out here. Those all have the same geometry, the same atom placements and packing. And so we will sometimes refer to these as a family of planes since they're all identical. And the family of planes, if you see it written, will look something like this with curly braces. But I'm going to generally avoid that for this class. All right, what about the body-centered cubic? Let's go ahead and take a look at the 1, 1, 0 plane for the body center cubic. So again, this means that intercepts is going to be 1 on the x, 1 on the y, and then parallel to the z. So we'll go ahead and draw that. We've got an intercept of 1, 1, right? We call this our A, our B, and our C directions. And so I've got those two intercepts. And then since it's parallel to the z, then I know that my plane then looks like this. So that's the plane we're going to sketch. What do I see? I've got atoms at the corners, and I've got an atom right here in the middle, right, located at the 1/2, 1/2, 1/2 coordinate. And that one's also on this plane. So now to sketch this, I'm going to have to think again about my space filling model and realize that my atoms touch along the body diagonal. Okay. And so in terms of this plane, let me change my color for a second here. This means the atoms are touching, right, along these body, terrible line, along these body diagonals. And then from this one to this one. I think that's the plane that I want to sketch. All right, I know that's a bit of a mess. So here it is with atoms labeled. And now when you're sketching a plane like this one, notice this is not the same as the 1, 0, 0 that we sketched for the face-centered, although it looks similar, but it's not square any longer, but a rectangular plane orientation. So this is A, our lattice parameter, which would be this dimension here. And then we're cutting across the face, so this is A square root 2. Right? So that's this distance here is A square root 2. So that would be my rectangular placement of the atoms. And so I do want to label that. Or if I'm on a test where it's multiple choice and you see these sorts of labels, it's trying to tell you that this indeed is supposed to be rectangular and it's not square. So it's just very important. And then again, they're touching, you can see here now along these body diagonals. Okay, so that's it. Good luck. See you next time.